Right now, tech companies are racing to build the most advanced, like seemingly weightless, cloud-based artificial intelligence in human history.
Yeah, the ambition is just staggering.
It really is. But the thing is, to actually do it, they are quietly buying up something entirely different. Like we are talking nuclear reactors, water rights, and just massive amounts of concrete.
Right, the physical stuff.
Exactly. And if you look at a stack of today's headlines, it can honestly feel like you were just staring at a completely random assortment of puzzle pieces. I mean, you've got a story about the latest AI model breakthrough right next to a piece on local zoning
Which
laws.
seem totally unrelated.
Yeah, totally. And then you turn the page and you're reading about international naval operations in the Hormuz Strait and then a report on municipal water usage.
Yeah, it looks like 5 or 6 completely different categories of news. You take environment, local politics, global security. But the reality is actually much more cohesive than that.
And that is the mission for our deep dive today with you. We are going to explore a massive structural change that is happening right under our noses. What if these aren't separate news stories at all?
Like, what if it's all one story?
Exactly. We are watching AI transition from a purely digital phenomenon into a massive, heavily constrained physical infrastructure system.
What's fascinating here is that we are entering a phase where the digital world is slamming into the hidden constraints of the physical world.
Right.
Because, for a long time, the internet, cloud computing, and AI, they all felt kind of ethereal. They were just code floating in a server somewhere.
Like magic, almost.
Yeah, exactly.
Yeah.
But that illusion is breaking. We are observing this incredible collision between the limitless ambition of technological capital and the very real, very rigid limits of the physical Earth.
And as we get into this with you, we really want to set the tone here. This isn't just a simple news summary, and we certainly don't claim to have all the definitive answers.
No, definitely not.
Think of this as more of an investigation into these emerging systems. So let's start with the fundamental shift. Because for years, the entire discourse around AI has been completely obsessed with the digital side.
Right, the global race for GPUs.
Yeah, GPUs, the architecture of semiconductors, the parameter counts of these huge language models. The conversation was entirely focused on computation.
Well, the focus was on the brain of the operation, you know. But suddenly the bottleneck isn't the brain anymore, it's the body.
Oh, I like that way of putting it.
Yeah, the sheer scale of the physical requirements to power that computational brain is now it's too large to ignore. To really grasp the mechanics of this, we need to look at the physics of training and running these models, which is actually reflected in a recent UN university report.
Right, that report is wild.
It really is. So in 2025, estimates show data centers are using roughly 448 terawatt hours of electricity globally.
And to put 448 terawatt hours in perspective for you listening, that is more electricity than entire industrialized nations consume in an entire year.
Yeah, it's an astronomical draw on the grid.
It's just massive.
And alongside that power, they are consuming roughly 1.2 trillion gallons of water. But the structural friction here comes from the trajectory, because by 2030, which is just a few years from now, both of those figures are expected to double.
Double in 5 years. Wow.
Yeah, data centers will consume roughly 3% of the total global electricity demand. We are talking about a massive redirection of the world's energy generation.
Okay, let's unpack this because I think we need a mental model to really visualize why this is causing such a shock to our system.
First, let's do it.
It's like we built a 100-story digital skyscraper. And we spent years obsessing over the software of the building, right? Like the automated elevators, the smart windows, the architectural design of the lobby.
And the shiny stuff.
Exactly. But unlike a normal office building where people go home and the lights shut off at night, every single appliance, elevator, and light bulb in this digital skyscraper is running at 110% capacity 24 hours a day.
Just permanently drawing power.
Right, permanently drawing from a neighborhood electrical grid that was frankly only ever built to support residential houses. And now the transformers down the street are starting to spark.
That is a great analogy. The mechanism you're describing there is essentially a profound speed mismatch.
The speed mismatch.
Yeah, on one hand, you have AI demand, technological innovation, and investment capital. Capital is fluid, right? It moves at lightning speed. You can wire $1 billion to a tech startup in seconds.
Sure.
But on the other hand, you have physical infrastructure. Building a new gas peaker plant or upgrading electrical substations, securing water rights, laying heavy copper transmission lines. That stuff moves at the speed of concrete.
It takes years, decades even.
Exactly. You can't just write a new line of Python code to generate a high-voltage power line.
So you have the velocity of software colliding head-on with the inertia of the physical world.
And when those two fundamentally different speeds interact, you get structural friction. The infrastructure simply cannot keep up with the computational demand.
Which brings us to the actual real-world examples.
Yeah.
Because I want to take us from those massive global UN statistics down to the ground level to really see this speed mismatch in action.
Let's do it.
Let's look at how data centers are quite literally forcing themselves into the operating systems of major cities. Our sources highlight 3 very different locations experiencing this exact friction, starting with the Kuala Lumpur and Johor regions in Malaysia.
Yeah, Malaysia provides a very clear look at the thermal and electrical limits of a regional grid. You have Equinix building a new $190 million liquid-cooled data center there, specifically aimed at AI and high-performance computing.
But the timing is just brutal. The region is experiencing severe heat waves, which already pushes the local electrical grid to its absolute limit because you know everyone is running their air conditioning.
Right, the baseload is already maxed out.
Exactly. So when you introduce the massive, relentless energy draw of this new data center activity on top of a heat wave, the local infrastructure just bends.
It has to.
The data from our sources shows that gas-fired power generation in the area has been pushed up by more than 50% year over year.
50%. That is wild.
It is. The AI demand is quite literally altering the fossil fuel burn rate and energy generation profile of the entire region.
Wow. Well, if Malaysia represents the breaking point of the physical grid, Santiago, Chile represents the breaking point of the community living underneath that grid.
Okay, how so?
So AWS is pushing a major data center project forward in Santiago, but they are hitting a completely different kind of friction. It isn't just about plugging the servers in. It's about the physical footprint of the operation.
Right, because the local residents are pushing back hard.
Exactly.
The friction there is centered around environmental reviews, the visual and physical impact of massive new power lines cutting through neighborhoods, and the enormous water usage required for cooling.
Yeah, it's the intangible idea of the cloud crashing into the very tangible reality of a neighborhood's backyard.
Which naturally leads us to a third type of friction. If you resolve the grid issues and you somehow manage the community pushback, you still hit the internal regulatory limits of the city itself.
Right, the municipal level.
Yeah, like in Seattle, you have Amazon employees actively petitioning the city council to strictly regulate data centers.
And they aren't just asking for minor tweaks either.
No, not at all.
Mhm.
These employees are demanding that the city address core municipal issues. Things like new taxes, the mandated use of renewable energy, strict energy storage requirements, and labor safety around these massive facilities.
It really forces us to ask a critical question about urban design. Are data centers simply industrial buildings anymore? Or are they becoming deeply entangled critical components of a city's fundamental operating system, like a city OS?
Wait, let me play devil's advocate here for a second.
Go for it.
Haven't we always had massive industrial factories? I mean, we've had sprawling steel mills, huge auto manufacturing plants, and chemical refineries that use gargantuan amounts of power and water.
Sure, we have.
So why is an AI data center the straw that breaks the camel's back? Why is this a completely new paradigm for a city to handle compared to an auto plant?
That is a great question. Because a traditional steel mill or an auto plant can often ramp its operations down during peak grid hours. If the city is experiencing a severe heat wave and power is scarce, a traditional factory can adjust shifts or delay a production run.
They can just turn the machines off for a bit.
Exactly. But an AI data center has zero tolerance for downtime. The entire economic model of AI relies on keeping those highly expensive GPUs running at maximum utilization constantly.
So they have to run 24/7 just to justify the billions of dollars spent on the hardware in the first place.
Right. That constant unyielding draw is one factor. The second factor is the speed of deployment.
Which goes back to the speed mismatch.
Yeah, traditional manufacturing usually grew alongside a city over decades.
Yeah.
Local utility, the water board, and the factory, they kind of all evolved together.
Yeah.
With AI, the capital investment is so massive and moves so fast that these facilities are being dropped into existing open grids almost overnight, demanding a huge percentage of the city's resources immediately.
Wow.
The urban operating system simply doesn't have the time to adapt to the shock.
So the sheer velocity of the deployment completely breaks the municipal planning cycle.
Exactly.
If cities all over the world, from Kuala Lumpur to Santiago to Seattle, are struggling this much to integrate AI infrastructure, it really suggests we are fundamentally miscategorizing what AI actually is.
Yeah, we really are.
Up until now, I think the general public has viewed AI purely as an information industry. It's software, it's code, it's an app on your phone.
Right. But if we connect this to the bigger picture, we have to start recognizing that AI is transitioning out of the software category. It is increasingly acting as an energy industry.
Yeah.
It is a heavy infrastructure industry. It is literally an urban development industry.
And the regulatory bodies are certainly waking up to that reality. Like, the European Union isn't just looking at data privacy or algorithmic bias anymore. They are currently preparing minimum energy efficiency standards and comprehensive sustainability labels for data centers across the continent.
And those labels are very revealing. They specifically mandate reporting on water usage and the reliance on clean power.
Which is huge.
It is. The EU is anticipating that their continental data center capacity is going to jump from 12 gigawatts in 2025 up to 28 gigawatts by 2030.
And to put a gigawatt into perspective for you, a single large nuclear reactor produces about 1 gigawatt of power.
Right.
So the EU is trying to build a regulatory framework to manage the equivalent of adding 16 nuclear power plants worth of demand in just 5 years.
It is hard to even comprehend that scale.
Yeah.
And we see the exact same shift playing out on a geopolitical level in Central Asia. Kazakhstan, which is a massive resource-rich nation, just signed a nuclear power contract with Russia.
Yeah.
But the crucial detail in our sources is that this nuclear contract is happening simultaneously with Kazakhstan's push to build large data centers and heavy AI infrastructure.
Now, as we discuss the actions of the EU or the geopolitical contracts between Kazakhstan and Russia, our goal here is to remain strictly neutral and objective.
Absolutely.
We aren't taking sides. We are simply reporting on the structural shifts in global governance. What we are observing in Kazakhstan is a nation attempting a fascinating economic pivot.
Right. They're moving from being a traditional petrostate where they just export raw minerals and oil to attempting to become what you might call a compute state.
A compute state. That is a wild concept.
Yeah, they want to process data domestically powered by their own heavy nuclear infrastructure rather than just exporting the raw energy.
It perfectly illustrates the physical transition of the industry. The geopolitical advantage is no longer just about who has the best coders in Silicon Valley. It's about who has the baseload nuclear reactors and the transmission grid to actually turn those algorithms on.
Exactly. But as much as we focus on electricity and, gigawatts and nuclear power, always get the flashy headlines, there is a quieter, heavily calcified constraint that is completely flying under the radar.
Oh, right. It is the ultimate bottleneck. Water.
Water. Yeah. Let's go back to that staggering UN statistic. 1.2 trillion gallons of water.
Which is just an unfathomable amount of liquid.
It is. So why does a computer program need 1 trillion gallons of water?
Well, it comes down to the physics of the new semiconductors. The latest AI chips, like the advanced GPUs used for training large models, are essentially incredibly dense space heaters.
Yeah, they really are.
They process so much data so quickly that the thermal output is immense. Traditional air cooling, like just blowing cold air across a server rack, is no longer physically sufficient to keep the chips from actually melting.
Right. Air simply cannot absorb and carry the heat away fast enough.
Precisely. So water is significantly more efficient at absorbing heat. Because of that, the industry is moving to advanced liquid cooling systems.
But this isn't a closed loop where the same water just goes round and round indefinitely.
No, not at all. In many of these massive evaporative cooling towers, millions of gallons of water are used to absorb the heat, and then that water is evaporated directly into the atmosphere to release the thermal energy.
Oh, wow.
Yeah, it is consumptive water use.
Yeah.
It is gone from the local watershed.
Wow. Here's where it gets really interesting. Think about the incredible historical irony here.
Okay, lay it on me.
We are developing the most advanced futuristic technology in human history. Artificial intelligence that can simulate protein folding or write complex software. And yet its very existence is fundamentally bottlenecked by one of the most ancient, primitive constraints of human civilization.
Local water rights and river access.
Yes. The irony is profound, and it completely rewrites the real estate playbook for the tech industry.
It really does.
The availability of a stable water table is quietly becoming the most critical site selection criterion for a new data center. Securing the local legal rights to draw millions of gallons from an aquifer might soon be more difficult and honestly more strategically valuable than having the venture capital to buy the GPUs.
Wow, that puts it in perspective.
Because a tech company can always contract a foundry to manufacture more silicon chips, but they cannot manufacture a new river.
They really can't, which actually brings us to the final and perhaps most surprising puzzle piece from our headlines: global security and naval operations.
Right.
Because AI is now an energy and infrastructure game, it is instantly and permanently tied to global physical logistics.
Everything we've discussed so far, electricity, heat, water, it all ultimately relies on the global energy supply chain.
Right.
Let's pull in that seemingly unrelated headline about the European Union naval mission.
Right, the ASPEES mission.
Yeah, ASPEES, which is proposing to lead mine clearance operations in the Hormuz Strait.
Wait, let me make sure I'm following this chain reaction. Are you saying a naval mine in the Middle East could literally make running a query on ChatGPT too expensive? Like, how direct is that link, really?
Oh, the link is incredibly direct. Roughly 20% of all global oil and liquefied natural gas transport passes through the Hormuz Strait.
20%? Wow.
Yeah, it is arguably the single most critical energy choke point on the planet.
So if a shipping lane is blocked, natural gas supply drops.
Exactly. And when global natural gas supply drops, the price of fuel spikes. And because grids rely on natural gas peaker plants to meet the marginal spikes in electricity demand, especially when massive data centers are drawing power 24/7, the cost to generate that electricity skyrockets.
Oh, I see.
So when electricity costs spike, the operational cost of running AI infrastructure globally just explodes.
So geopolitical energy routes are now, by definition, AI compute routes. Protecting a shipping lane in the Middle East isn't just about keeping the price of gasoline down for commuters anymore. It's about keeping the global data centers online. It's about ensuring the physical lifeblood of the digital economy isn't severed.
Yeah, the supply chain for artificial intelligence is no longer just silicon wafers and fiber optic cables. It is liquefied natural gas, it is uranium, it is municipal water pipes, and it is naval security in global shipping lanes.
So what does this all mean for you? We've covered a massive amount of ground today, from the physics of thermal cooling to Malaysian heat waves, EU energy regulations, and naval missions in the Hormuz Strait.
We really have.
For you listening, we want to crystallize the core structural change we've been investigating.
Right. The central takeaway is that the era of AI scarcity being defined by digital limits is essentially over.
Right.
For the past few years, the bottleneck was entirely digital and manufacturing-based. It was a race to see who had the smartest mathematical model, who had the most innovative software engineers, and who could hoard the most advanced semiconductors.
But that landscape has shifted completely under our feet. The actual constraint today, the real ceiling on how far and how fast AI can grow, is the physical systems required to sustain it.
Absolutely.
We are talking about the sheer physics of electricity generation. We were talking about the evaporative capacity of local water tables. We are talking about urban zoning laws, community tolerance, and the physical resilience of global energy logistics.
The digital world, which operated under the illusion of infinite scale, has finally hit the physical wall.
And that wall is made of water, concrete, and copper wire.
Yes, it is.
This shift should completely change how you process the news from now on. The next time you see a headline about a shiny new AI model or a multi-billion-dollar investment in a tech company, look past the software.
Look for the hidden physical footprint.
Yes, ask yourself, where is the baseload power coming from? Whose local aquifer are they evaporating to keep the chips cool? How is the local city council reacting to the strain? Because the mechanics of those physical constraints are where the real story of the future is being written.
This raises an important question, and it is something we want to leave you to mull over as you go about your day.
Okay, let's hear it.
We've established that the global competition is shifting away from who simply has the best semiconductors and moving toward who has the electricity, the water, and the resilient urban operating systems to support them.
Right.
If that is true, which cities in the world are about to gain massive strategic advantages as the new hubs of the global economy, and which cities are going to hit their structural limits first?